Welcome to this is grade 9 exponents. Before I start, if you didn't watch my videos for grade 8 mixed operations and grade 8 simplified, please do it before you watch this video, because in the grade 8 I go into detail how to do the operations, so you'll pick up a lot of tips and tricks that will help you going forward. What I'm going to do in grade 9, I'm not going to explain all the detail. I'm going through a much faster pace, because if you know the grade 8 work, then this should be much easier for you. Just before we start, this is the exponents, the index laws. So I just need you to either write it down or make a copy of this, because you're going to need these laws going forward. So these laws are extremely important from grade 7 right up to grade 12. And if you know these laws, then exponents will be easy for you to do. Okay, let's start. I'm going to do a lot of examples, different varieties, so that you can see and understand exponents. Right, so let's start. So a to the power 3 times a4 divided by a minus 1 times a to the power 13, and all of that to the power 4. So we're going to simplify all of this. So if you look at the laws on the previous page, let's keep that in the bracket. The a3 times a4, that part becomes a7, because you're going to say 3 plus 4, and at the bottom you're going to have 13 minus 1, which is 12. And then here you're going to have a7 minus 12, all of that to the power 4. I just took the minus 12 and I took it up, then it becomes 7 minus 12, and that answer becomes a. 7 minus 12 is minus 5. And if you look at the laws, the index laws, I'm going to use law 3. You just multiply the minus 5 by the 4, and then you get a to the power minus 20. And just double check. A3 and A4 is A7. This one is a 12. And then you have A7 minus 12 is a to the power minus 5. And then all of that you multiply, and then you'll get the a to the 20. Good. So that's your answer. That's the first one. Next, we have x squared y to the power 3. All of that divided by x squared. So here, you can't do this at this stage. For normal x squared over x squared, you could have done that. But you can't do that. Why not? Because we are sitting here with this part over here. This is a bracket. And we must first multiply the bracket before we work with anything below the bracket. So we're going to do this part later. Let's first work inside the bracket. So we're going to do the x squared times y. So we're going to break this up. But what I'm going to do here, I'm going to do this. X squared to the power 3, and then y to the power 3. All of that divided by x squared. And all of this, I'm just using the laws. So for this one, I use one of the laws, and then it's much easier for you to do if you keep your laws handy. So for this part of the year, you just multiply the 2 and the 3, which is x6 times y3, and all of that divided by x squared. Now, here you have x6 and x squared. And if you do that part on its own, then you get x6 minus 2, and then the y is just the y3. And then the x is going to be the 6 minus 2, and that equals 4. So let me just write it in normal color. So the answer is going to be x4 times y3. So that is how you simplify it. Let's continue. X to the power minus 5. Y to the power 3. All of that divided by x squared. Y 6 to the power 0. So let's see what we have here. If you look on your index page, law 7, then you will see you have x to the power 0 equals 1. Now, anything to the power 0 equals 1. Y to the power 0 equals 1. P to the power 0 equals 1. So anything to the power 0 equals 1. And if we do that, let me just wipe this out. And if we do that, then we're going to say here, this part here at the bottom, that to the power 0, because that is inside a bracket. And all of that to the power 0 will give you 1. So below the line, we just have 1. And on top, we have the x to the minus 5 and y 3. And usually, when we do stuff like this, they want the answers all positive, and then we sit with a negative. So what we do here, we're just going to keep the y3 on top and just bring the x to the bottom, and then it becomes 5. So the x was minus 5 on top. Now it just becomes 5. I'm just double checking if my work is correct. So that looks good. Let's continue. Here we have P, Q to the power 3, and R, all of that to the power 4, divide by P3Q, and all of that to the power minus 3. So let's see how we can break this up. So I'm going to take everything inside of this bracket, and I'm going to multiply that to the 4, so that we can just look at the sum properly. So I'm going to take P to the power 4, and I'm going to take Q3 times 4, so that's going to become Q12, and then R is going to become R to the 4. So what I've just done, let me just show you, if there's nothing by the P, there's actually a 1, nothing by the R is a 1, so I just multiplied the 1 and the 4, that gives us the 4. With Q, I multiplied the 3 and the 4, that gives us 12. And for R, I multiply the 1 and the 4, and that gave us this 4. We still have the below, so I'm going to do exactly below. I'm going to multiply the 3 with that, and here on Q, you have 1. So I'm going to multiply the 1 times the minus 3. So below the line, you're going to get P times 3 times minus 3. That answer is minus 9. And then Q, 1 times minus 3. That answer is minus 3. So 3 times minus 3 is minus 9. 1 times minus 3 is minus 3. Let's continue. So now you have P's and Q's. So I'm just going to try to group it together. So let's take the P9, this minus 9. Let's take it to the top. And then I'm going to take this minus 3 also to the top. And then let's see what we get. So here we're going to have P, 4 plus 9. If I take the minus 9 to the top, it becomes a plus. Then we have a Q, 12 plus 3. And then we have the R. So I took this minus 9 to the top, it becomes 4 plus 9. The minus 3 I took to the top, and it becomes 12 plus 3. And the R, there must still be a 4 over there. And now you just add this up. 4 plus 3 is 13. So that becomes P13. And Q, 12 plus 3, that answer is 15. And the R is 4. And that is your answer. Let's do something different. 2 to the power minus 4 divided by 5 to the power minus 2. So if we have something like this, what I'm going to do, I'm going to swap it around. And what I mean by that, the 2 to the minus 4 is going to become 1 over 2 to the 4. That means this here is going to the bottom, and that's going to become 2 to the 4. And this 5 to the power minus 2, I'm going to take to the top. And if I take it to the top, then it becomes 5 squared. The minus 2 becomes a plus 2. So now it looks a bit better. It looks like something that we can work out. So let's continue. You're going to wipe this out here at the bottom. So let's continue. 5 squared. That gives us 25. 2 to the power 4. So that's 2 times 2 times 2 times 2. That is 4. That is 4. So that answer is 16. So then the answer is 25 over 16. Good. Let's go on to the next one. Similar one. Here we have 3 to the power minus 3 divided by 2 to the power minus 4. We do exactly the same. The minus does go to the bottom, and I'm going to take this to the top. The only reason I do that is because I just want to change the signs from negative to positive. So the 3 to the minus 3 goes to the bottom, becomes 3 cubed. The 2 to the minus 4 I take to the top, and that's 2 over 4. That's the same one we did now. So that answer is 16. At the bottom, you have 3 to the power 3, which is 3 times 3 times 3. That equals 9. 9 times 3 is 27. So then you have 16 divided by 27. I'm going to keep it like that for now. You just have to check with on your page exactly how you should write it, but this is the smallest that I can write it for now. Okay, let's continue with another to include some x's in the mix. So now we're going to have minus x squared to the power 5. I'm just showing you different examples so that you get used to anything that they might ask you in the exam. So here we have a minus. So if there's nothing, there's a minus 1. So leave that for now. I'm first going to do this part over here. I'm going to do that first, and then the blue part I'm going to do second. So let's do the green part first. X squared to the power 5. That becomes x 2 times 5, which is x 10. But don't forget the blue, which is the minus 1. That must continue all the time. So I'm just going to do that. I'm writing the minus 1 so you can just see that there must be a 1 in front of it, equals that. So you don't need to write it, but I'm just showing you there's nothing in front of a number, then there's a minus. But at the end, you can leave the 1, and the answer will just be minus x to the 10. Let's do this one. I'm sitting with a Pythagoras book that I used to study when I was in school. And I bought it at P&A. Very nice book. All these examples I have in my videos, I take out of that books. And it's from CAPS as well. So they use the exact same syllabus that school are using. Right, so let's continue. X to the minus 4 times that. So everything is fine. So I'm just going to multiply that with each other. Then the answer is x to the power 4 minus 4 times minus 2. That answer is 8. Let's do the next one over here. So as you can see, each sum is different. This one is a plus over there, and this one is a minus. So that's why I'm just showing you different examples. So what we're going to do here, let me just think. So we're going to multiply. So the first thing we're going to do is just look at the sign over here. That's a minus. So the minus, and you remember if there's nothing in front, it's actually a 1. So we actually have something like this. Minus 1 multiply by x to the minus 7, and then all of that to the power 3. So how we can do that is say we're going to take this first, the minus 1. I'm going to break up and then multiply by the to the power 3. That I'm going to do first, and then I'm going to do this part second. So the first part I'm going to do is minus 1 to the power 3. That answer is minus 1. And then keep that in a bracket for now. Then I'm going to do x minus 7 to the power 3. And that answer is x. So it's minus 7 times minus 7 times minus 7. So it's minus 7 times minus 7 times minus 7. So a minus and a minus and a minus gives you a plus. And 7 times 7, just working it out, 49 times 7 is 343. Oops, I made a mistake. Excuse me for that. You probably picked it up. This rule that we are going to do now is not minus 7 cubed. It's just minus 7 times 3. So minus 7 times 3, that answer is just minus 21. That's why I always double check my work, because if you see a lot of minuses and a lot of brackets, it can be confusing. So in stuff like this, I always double check my work. So let's just write this out neatly. The minus 1, we can just put the minus, and there we have the x to the minus 21. Let us just double check if everything is right. So we have the minus 1 we take out, and then the x to the minus 7, then the minus 1 times minus 1 times minus 1. That answer is this minus 1 over there. And then x to the minus 7, we just multiply this minus 7 times 3, and then we're going to get x to the power minus 21. And don't forget this minus sign over here. X up, you're going to have x to the power minus 9, and all of that to the power minus 1 over 9. So let's see what we do. Very simple, but what's important, we keep the x over there, and this minus 9, we're going to multiply by the minus 1 over 9. So let's just keep it separate first. Minus 9 times minus 1 over 9. So if there's nothing here, you can actually do that. The 9 cancel each other out. You have this minus and a minus, which becomes a plus. And then you have ones everywhere. So the answer is just 1. So it's going to be x to the power 1. So all of this part over here, if you multiply it out, and you can check it on your calculator, you will get the answer of 1, and then the answer is just x to the power 1. And if you neaten this up or simplify it, you can just write x. All right, let's do this one. X to the power 8, and all of that to the power minus 1 over 4. Very similar to the previous one, where you take the x, and now we're going to multiply the 8, multiply by minus a quarter. So let's do it over here. 8 over 1 times minus 1 over quarter. 4 goes into 4 once. 4 goes into 4. 4 goes into 8 twice. Then you have 2 times minus 1. That gives us minus 2. And you have just the 1 times 1. That gives us 1. So the answer is minus 2. And that minus 2 goes in here. And that becomes x to the minus 2. If you want to simplify it further, you can just write it like this. 1 over x squared. Just make all the signs positive. And then you can just bring this minus 2, take it to the bottom, and it becomes a plus. Let's do x squared all that to the power 6. But now all of this to the power minus 1 over 3. So we're sitting with a lot of brackets, but what's important is this is a bigger bracket, and then we have the smaller bracket in here. So let's first do the smaller one, which is x squared times 6. That will just give you 2 times 6. So inside the bigger bracket, I'm just going to keep this here on top for now. You're going to have x squared times all of that to the power 6. And for that, you just multiply the 2 and the 6. And for that, you're going to get x. 2 times 6 is 12. And now this is exactly the same like the previous one. And if you do this same like the previous one, you'll get the answer of -4. And then you can just write it out neatly, x to the power 4. I'm going to make it slightly more difficult now. X to the -8 times x to the -4, all of that to the power a quarter. So if you see something like this, what you're going to do, you're first going to look at maybe to split this up. So what I'm going to do, I'm going to take this part over here to the power quarter, and then this part over here to the power quarter. So let's make this green. Write that out and just keep it green so you can see what I do. So let's do the blue part first, which is x to the power -8, all of that to the power quarter, multiply, let's do the green, y to the power -4, and all of that to the power quarter. Let's do this part. Now you see it's the same like the others. This answer is going to be -2. And then the green part, you're going to have y to the power -1. Currently, both is negative. So to change it positive, you just take it to the bottom of a line, put 1 on top, and just say 1 over x squared times y. It's actually y to the 1, but you don't need to write the 1 if the 1 is a positive. So you can write it, but you can take it away. Then that's going to be your answer. And let's do the last example like this one. We have x 9, y to the power -27, all of that to the power third. So let's see again, can we break it up? Let's make the x to the power 9 green. Let's make y to the -27 blue. So I'm just going to show you something else before I continue. What I'm actually going to do here is just do this. Put the x9 in a separate bracket, put the y -27 in a separate bracket, and then all of that is multiplied to the power up to the power third in the bigger bracket. So now you can see more clearly why this is green and that's blue. And now I'm gonna do the same like the previous sum and multiply each one of that to the power a third. So let's start with the green. We have x9 to the power third times, then we have the blue part, y to the power -27, all of that to the power third. Then this answer will give you x9 divided by 3 is 3. And the blue, we're going to get, I'm just going to write it separately here, -27 times a third gives us -27 over 3, which equals -9. So the y is just going to be -9. And as you can see here, what I did, I just usually write this on a separate side just to work it out, just to ensure that I have it right, just to keep this part over here nice and neat. While we are busy with exponents, I'm just going to do a couple of simplification examples so that you can just understand the exponents better. You should understand it by now. So if this is easy for you, then well done. Then you've done very well because you understand the maths. So let's do this. You can remember is first this times that, then the second one, and then the third one. So the answer is going to be 2x to the power 5, because remember, I'm going to add that up, 3 plus 2, and I'm going to do that the same with all the other ones. Oops, not to the power, yes, to the power 5. The next one is going to be 10x to the power 7, and then minus 2x to the power the power 4. Let me just remove this blue over here. So I think that is confusing me. Let's just double check again. 2x to the power 3 times x squared, yes, gives us 2x to the power 5. This one times that gives us 2x to the power not 7, but 9. So there's a 3, there's a 6. So that 7 is wrong. That 7 should be 9. Again, very important. That's why I always double check my work, because this is where you can make simple mistakes. And if you get a simple mistake like this wrong, and then your whole sum is wrong. So x3 and x6 gives us x9. And then the minus the 2x to the third times minus x gives us minus 2x to the power 4. That looks right. We don't have any like terms now, because this is x to the power 5, this is x to the power 9, this is x to the power 4. So for now, I'm just going to keep it like that and not simplify it any further. Let's do another example. x5 times x squared minus x plus x7. So again, do that first, then that second, then that third. So the answer is going to be x to the power 10 minus x to the power, remember there's nothing there, there's a 1. So 5 plus 1 is 6. And the last one is going to be x, 5 plus 7, which is 12. And for now, we're just going to leave it like that. Just double checking. That times that is minus 6. And x to the 5 times x to the 7 gives us x to the 12. Let's do something with a minus in. Minus x squared times, that's x, sorry. So minus x squared times x to the power minus 5 plus x to the power 8 minus 2x to the power minus 7. Going to do that part first, then that part second, then that part third. So what answers are we going to get? So for the first one, I'm going to get minus, that's x2 minus 5 is a minus 3. Then the second part we're going to get, this is the minus x squared times x8. We're going to get minus and a plus is a minus. That's going to be x to the 10. The last one is going to be plus 2x to the power, and 2 minus 7, that is minus 5. Just double check. Minus x to the minus 3, that is minus x to the power 10, and that is plus 2x to the power 2 minus 7, which is minus 5. So that looks correct. So why I'm just showing this is just all these minuses that you minus with each other. But like I mentioned at the beginning, just please look at that 2 videos I mentioned. I'll put a link in the comments later on, and then you can access it easily. Let's just do something different. Here we have x2 plus x5, and all of that x5, all of that over x squared. So let's just see here. It looks a lot, but let's just break it down and first do this part over here. And if we do that, we get x. And I'm just thinking how we can't do that, because I wanted to multiply out, but we can't multiply out because there's a plus. So let's just start all over again. x squared. So what we can do, okay, here we have a x squared, and in here is also a x squared. I'll show you how. So we have the x squared over here. This is part of factorization. We have x squared over here. If we take it out, then we get x, not x, we get the 1. And then here we have x to the power 3. All of that divided by x squared. This will cancel out. And then you only have 1 plus x3. So that's why if you look at the any mathematical question, always just think about your approach. So for this one, I went in too fast. That's why I had to backtrack again and just see how I could have done it better. So for, like I mentioned, this is part of factorization. So please look at my factorization video, because in there I will show and give a lot of examples about factorization. Now, again, something different, still with exponents. We're doing exponents the whole time, but I'm just showing you different questions about exponents. So here we now have solve for x. If you have an x and an equal sign, there's the x, there's an equal sign. If you have something like that, always know you want to end with x equals something. So that is what we want to work towards. So let's take the 2x, keep it like that. So what we're going to do with the 64, we're going to try to break it out and see if we can write it in 2 to the power something. So if you work it out, so you're going to do it separately here and use another color. So 2 times 2 gives us 4, times 2 will give us 8, times 2 will give us 16, times 2 is 32, and the last 2 will give us 64. So if you count the number of 2's, we have 1, 2, 3, 4, 5. There should be another one there. So if you multiply 2 with itself 6 times, then you'll get 2 to the power 6, and that answer will be 64. So what can we do with that? We can actually put that 2 to the power 6 in here. And now you can see here you have a 2 and a 2, which is the same. And because on top is x and a 6, but because the 2's are the same, that x equals that 6. So then the answer is just x equals 6. So as you can see, if we do something like this, the aim is always to get the base the same. And if the base is the same, then the 2 numbers on top will also be the same. Let's do another example. 3 to the power x equals 27. Oops, 27. So we can say 27 is 2 to the power whatever, but we don't want to do that. Why not? Because there is a 3. We ideally would want 3 over there to the power something. So that is what we want to work towards, is to take this 3 or this 27, convert it into 3, because once we have a 3 to the power something, whatever we're going to get to the answer now, then this x and that will equal each other. Why? Because the base are the same. So let's see what we can do. So 27, let's take not 2, but let's see if we can do 3. So 27, or ask yourself, what is 3 times 3? That is 9. And if we take 9 times 3, okay, then we get 27. So what we can actually say is 3 times 3 times 3. That gives us 27, which is, so 27 is 3 to the power 3. And now we can put it in here. 27 is 3 to the power, and we remove that over there, and we can now put the 3. And like I mentioned earlier, because the base is the same, we can now just say that x over there equals that 3 over there. And that is your answer. X equals 3. Here we go. Let's do another one. So now everything like this is the same. We have x to the power 4 equals 81. But just keep now in mind, in the previous sum, we had the 2 as the base. But now we have the x as a base. So now we don't want the x at the bottom on the right-hand side because we don't have an x. Now we want to end with something like this. Something over here to the power 4. Why? Because that 4 and that 4, if that is the same, then we can say this x will equal that number over there. So that is what we work towards. So always, like I mentioned, approach your sum and see what you go. So there's a 4 to be, so we want that. So let's just assume we're going to get that for now, and let's see where we can go. So let's start how we can get there. So we want something to the power 4. So let's start. What is 2 to the power 4? If you work that out, you get 2 times 2 is 4, times 2 is 8, times 2 is 16. So that is 16. We don't really want that. We actually want 81. So the answer, something to the power 4, must equal 81. So let's see. 3 to the power 4, what do we get? Okay, 3 times 3 is 9. 9 times 3 is 27. 27 times 3, oops. 27 times 3. What's that answer? Is 1. Is that 81? 27, 27. 7 plus 7 plus 7 is 1. There's a 2. Okay, that gives us 81. For a moment, I just had another number in my mind. Okay, so that means 81 is 3 to the power 4. And now, like I mentioned earlier, because we have this 4 and that 4 over there, and now we have the x at the bottom and the 3, and now we can just say the answer is x equals 3, which is very important. Just if you think about this, is to know your exponents, 2 to the power 2, or your to the power 3 exponents, etc. And once you know that, then the answer will become much easier. 2 times 6 to the power x equals 72. Now the same like we did the previous sum, let's remove the 2. So let's take this divided by 2. We have to take 72 divided by 2. Then this answer is the 2's cancel each other out. So we're only going to sit with 6 to the power x. And on the right we have 72. And if we do this like we did the previous sum, then we are going. I see, you saw what I did now. This is not 72. Yeah, 72 divided by 2, that gives us 36. Again, important, double check your work. Even I do. Sometimes I work very fast, and if I double check my work, then I see I've made a mistake. So 72 divided by 2 is 36. What is 36? That equals 6 to the power 2. Why am I writing the 2? Because like we did the other sums, I want to keep this the same. And if the base is the same, then that x and that 2 will equal each other. So the answer will just be x equals 2. Let's do one last one. I'm going to have 5x. Just write it on top. 5, not 5x, 5 to the power x equals 1 over 125. So now let's just see what we can do. Remember at the end, we want something like 5 to the power something over there. So let's just see if we can work towards that. So here we have 5 to the power x. if we look carefully, 125 equals 5 times 5 times 5, which equals 5 to the power 3. So here we already have 125 equals 5 to the power 3. So let's write that over there, 5 to the power 3. But this 5 over here and this is not the same. The base is not 100% the same. So let's see if we can change this here to make it, put a 5 at the bottom. And how can we do it? We are going to say 5 to the power minus 3. And therefore, if we have something like this, okay, now we have 5 to the power x equals 5 to the power minus 3. And because the base is the same, what's the answer going to be? Yes, x equals minus 3. There we go. Thank you. That was exponents. I hope you enjoyed this. I hope you've learned from this. And if you're still stuck, just go over it again. And as you can see, the more you watch it, the more you will understand what we are doing. Thank you very much. Goodbye.